welcome everybody to my talk about lessons learned about exposed analogues for understanding Variscan geothermal reservoirs. The study of exposed analogues is of course a classical tool also applied in the oil and gas industry, but the special challenges we have on the geothermal reservoirs, and especially in our project on Variscan rocks, which have not been investigated before in this extent as analogues. Why Variscan rocks? Variscan rocks are very widespread in Europe, and this is one of the aims of our MEET project to develop geothermal systems in a wider and at a large scale in Europe. This map shows all the potential areas we have with the Variscan rocks. In orange and red, we see the granitic rocks and the crystalline rocks, and in gray we see the extensional fold and thrust belt of the Variscan. And what else do we see? We see the demonstration sites inside these red circles in Göttingen, in Sulz-sur-Forêt, in Avalanche, and in Cornwall in Redruth. Of course, these Variscan rocks have no natural permeability, so the main goal of MEET is also to apply and to develop enhanced geothermal systems. So we have to enhance these reservoirs by stimulations. This is a short overview of my talk. So after a short introduction to the demonstration sites, I present you the main aims of the analog studies, the key findings of these study areas, then of course the lessons we learned about the use of such analogues, and as a kind of conclusion, better integration in the analysis of geothermal reservoirs. So this is the classical figure of MEET, showing the 4 demonstration sites in these Variscan rocks. I already introduced that we are in granitic rocks in the lower part. So on the left side, it's Sulz-sur-Forêt in France, in the Vosges, and in Alsace. And we have a running power plant already with a stimulated reservoir in granitic rocks. To improve and to further develop such situations, such plants in such geological situations, we went to analog sites in the Vosges and in Southern California to well-exposed granitic rocks. And then we have another site, it's in Cornwall in England. During the MEET project, there were 2 wells set up and for power production. And for this demonstration site, we went also to exposed granites in the Cornwall area. Then in the upper side, we have the metasedimentary rocks and metavolcanic rocks. They are folded and thrusted. And we have one in Avalanche in Belgium. And the analog sites are in the Ardennes Mountains. And then we have Göttingen, where we have infrastructure already existing. So we have a district heating, but we have not much information about the underground. We have no well, and we go for the analog studies to the Western Harz Mountains. From this overview, you can see that we have very different technology readiness levels. So from a running power plant, from an operating power plant to quite underdeveloped sites in the metasediments. You see all the tools we applied for the different sites. Again, these figures show or give an overview of these different analog sites or in the underground, the geological situation. So we focus here on the granitic rocks and on the metasedimentary rocks. Sedimentary rocks were in other work packages of our project. And the aim, of course, is to characterize all these lithologies, the structures, and all the parameters which are relevant for our geothermal reservoir. You can already see from this right figure that especially in these folded and thrusted metasedimentary rocks, it's a quite challenging task to characterize such a complex reservoir. The aims of the analog studies. Of course, the aim is to make predictions about the subsurface geology of actual or potential geothermal reservoirs. And this includes, in our case now, different aspects and different parameters. And they are already published, if you want to know more details, in these deliverables. These are public available reports. Some of them are already available on our homepage and on Zenodo. And some of them, they are all finished, but some of them will be published or publicly available in the next days or weeks. So it was to measure the mechanical and thermal properties of the reservoir rocks. And then, of course, we produced parameters for the numerical modeling of the reservoir behavior. And one of our main focuses, of course, is the development of stimulation strategies. And this is what I present now in this talk, is mainly the characterization of the exposed analogues, including creation of new methods and strategies using such analogues. And as I said, one of the main goals is to develop enhanced geothermal systems. And we have quite different stimulation techniques like thermal stimulation, chemical stimulation, hydraulic stimulation or hydraulic fracturing, drilling side tracts, and also drilling additional wells. All these can be addressed as enhancements. I don't go into this table now. You can find all the details also in this deliverable, for example, deliverable 5.7, just to address the point of these stimulation measures. Let's go to the key findings from the 4 study areas. Of course, this I can make only very, very short, but again, the details you can find in the deliverables or in some of the publications already published or on the way. Again, a short overview of the demonstration sites all over the MEAD project. We focus now on the Variscan basement demonstration sites. And again, you see here the different technology readiness levels. So in Göttingen and Avalanche, so in the meta sediments, the level is started very low, and we could develop it now to a higher level. It means we are ready to drill in Göttingen and ready to convert this deep well in Avalanche to a geothermal well. So it's now a question of high money investment in these sites. And in the granitic rocks, they are major plays. Sulfur already running, more in the sense of an optimization. And in Cornwall, the wells are drilled and the plants are now under construction. Let's go at first to Sulfur as demonstration site. As we said, our group was in the Death Valley for better understanding the structures and lithologies of these granitic rocks. And there are three main findings. So 3 stages of metamorphism and alteration are distinguishing between a pervasive propylitic alteration and then a more local alteration producing clays, calcite and oxides, and weathering. So this is to better understand how the faults and the chemistry of the granitic rocks are composed. So this is also for learning how to run then stimulations. Then the group could show that several generations of fluids have migrated through the rock, and fracture networks have been quantitatively characterized and described in terms of a paleo-hydrothermal system. Then the other granitic site is in Cornwall, the United Downs project. And from the drilling course, it was possible to show that the rocks are very comparable on the outcrops, on the exposures. So the rock samples are enabled to predict the behavior of rocks in the subsurface. This is especially in this case for chemical stimulation of the well. And the exposed rocks allow to study the clay minerals, the composition, what again is important for the chemical stimulation, which is not possible from the drill cuttings because they are chemically alterated. And the exposed analogues enable correlations to make between petrophysical properties and mineralogical changes relative to hydrothermal alteration. So this is again the understanding mainly of the composition of the granites and the alteration processes. Then we go to the metasedimentary rocks in Avalanche, where we have this well. It's in length, it's 5,000 meters here. And so the exposed studies in the Ardennes Mountains show that the Pragian quartzites from the Devonian are considered to have the best potential as a geothermal reservoir. This is shown in this exposure here. And this shows one of our approaches on state-of-the-art techniques we used, we applied. So these are drone-based 3D models of the exposures, where we also could, or where we approached to make automatic analysis, for example, of the fracture networks. This was especially done in Death Valley also. And yeah, then the well log data have reinterpreted, and the whole section could be reinterpreted. And so this gave a new lithostructural interpretation. XRD, Raman, and SM scanning electron microscopy analysis and calcimetry have helped to understand the mineralogy and the degree of metamorphism, again for stimulation mechanisms. And additionally, and this is also quite interesting approach, so spring water samples show numerous physico-chemical indications on the active hydrothermal systems. This is an advantage in the Ardennes Mountains, that we have active hydrothermal systems. Then the demonstration site of Göttingen. So we have already a district heating system and a gas plane power plant, which should be replaced by deep geothermal energy. We could show, or we could characterize folds, faults, veins, cleavages, and joints. So all these structural elements which could be later stimulated. And one of the main issues was that we could show that slates can also be activated by stimulations, because we can prove that veins and joints developed in the slates, and so the slates as a quite weak rock is not a problem for reservoir development. Then, of course, we got information about lithologies, their mechanical properties, and so this helps us to make predictions about rocks beneath Göttingen. We focused also on the limitations between the exposures in the Harz Mountains and beneath Göttingen, and the limitations are mainly or include differences in the cover sequences, in the sedimentary younger cover sequences, and then in the post-Variscan structures, tectonic settings, stresses, and fluid pressures. And this is what we also tried to quantify and to discuss. But of course, at all sites, or mainly in these last two sites, we need more information from wells to validate all this information. What are the lessons learned about the use of analogues? I go quickly through that. One point is, or I go back to this, you can see that it's we have quite complex structures. So we always have to be very clear about the problems to be solved. In the beginning, we have, or in general, in such projects, we have a very large community of different experts, and it has to be really made clear in the beginning what are the questions. I don't go to all these details. You can find this also in the deliverables, but we developed a kind of evaluation concept. So before you start, you can go through all these questions and check if you have these informations. This is quite important, especially for the exchange between these different experts. I come back a bit to this point again. Then what I already pointed to is the understanding needs of other disciplines. So we as field geologists, we have to make clear that in this case, for example, modelers understand the data they need, and then we have to clarify if we can provide them or it's not possible, and especially the uncertainties in the field and what data we can really provide. Then the definition of geological terms, this is also very often not clear. And yeah, this so we need a common understanding of terms. And what I also already said, we have to clarify what analogues can really tell you and what they cannot tell you, because otherwise we produce wrong expectations, and we cannot communicate between modelers, engineers, investors, and so on. So that's quite important. And what I already also said, at the end, we need a well and information from the well at the site. And this also has to be really clarified when we apply for the high investment of a well. And then the choice of field analogues, this goes without saying, but again, this is quite important that you choose the right analogues. And it's not only one analog, you can also combine different analogues at different places just to learn and to clarify some points. I come back to this in the next slides. For example, the use of the term fracture. It has become common for fracture to be used as field description, but this means that key information are lost. Fracture is a very general term, and we really clearly have to divide between veins, for example, which are mineralized, joints, and the joints as they are. This is well shown here, and you can go to such clear exposures because, for example, in the metasedimentary rocks, this is much more complex and much more difficult to clearly understand. And with this question comes also paleofluids versus present-day fluid flow. Again, this is an exposure in sedimentary rocks. It clearly shows the mineralization, the paleofluid flow, and the present-day fluid flow, which alterates these areas along the joints. And also, sometimes a problem is that you are busy with distracting topics. For example, here for the reservoir characterization, we clearly have to stay on the points concerning the characterization, quantification of the structural elements for the reservoir characterization and less the tectonic development. Okay, so I come to the conclusions. How can we better integrate these analysis in the geothermal reservoir characterization? So Wagner et al. They developed an approach to this. So we have the main parameters here in this hexagon concept, and then you can quantify the quality and the quantity of these parameters in different levels. So in the ideal case, if you are here in level 10, then you have a real reservoir model which can make the best prediction for your underground reservoir. And this triangle zones, in our case in structural geology or in the exposure studies, the rock structures and the rocks itself and the discontinuities are the main important, so you can further split it up in more informations like here. Again, this is published in Wagner et al. And another point, if we now go in this evaluation of these reservoirs, it's also important to quantify the ranges and variabilities of our structural elements. And this is especially in these folded metasedimentary rocks, questions also in regard to scale invariance, because we can see exposures very well at outcrop scale, but if we go to the large scale and we have to quantify if we have a scale invariancy, or what are the special characteristics at different scales. This is still a quite challenging or quite big challenge to really quantify this. And then what also has to be very clear is what kind of modeling we use. For example, discrete fracture network modeling. This is for mature reservoirs like in Sulz, it's applicable, but for underdeveloped reservoirs like in Göttingen or in Avalanche, it's not possible to really quantify the fluid flow or to model the fluid flow. So we applied different modeling like the Moore circle approaches. This is already published. Yes, I'm finished in 2 minutes. Another point is we need more detailed and more precise workflows. This is also suggested in this deliverable 5.9. And at the end, what I said already different times, we are in an interdisciplinary project with geothermal reservoir development. So the communication and the knowledge transfer is a very important factor on this. Yes, so I'm coming to the end, and I like to thank to the whole team. I just represented the results of the whole team who were working on these analog studies in meat. And to everyone else, I thank for your attention, and you're welcome for questions. Thank you.